quote speaks to a great bit of truth to many students. Team 7 decided that finding a solution to the core issue of team-based studying would be the most worthwhile endeavor.
The first step in our journey was identifying the problem our team would attempt to solve. We wanted to find a problem with a rich solution space that was both widespread and appreciably consequential, but we didn't want to overextend ourselves by tackling something outside of our realistic scope. Naturally, we looked inward and thought about problems that had affected us personally. We skimmed over several problem spaces such as recipe suggestion and bus system improvements, but found that these spaces lacked depth and room for innovation. Eventually, we landed on a problem that had affected several of us personally, finding peers to study with. Collaboration is, and always has been, essential in any large-scale human endeavor, and learning is no exception. Decades of research have shown that studying in collaboration with peers is correlated with better academic performance, reduced anxiety, and most importantly, a more thorough understanding of the material at hand. At a large school such as UGA, it's not uncommon to be part of a class with upwards of 100 people enrolled. For younger students who've come from far away, students who may be shy, or anyone enrolled in a class without any personal friends, finding peers to study with can be a challenge. It seems strange to think that you can feel alone in a room with hundreds of other people, but it happens all the time. Our goal was therefore this: create something that allows students with minimal social contacts to find other peers to study with. Widespread, appreciably consequential, and within our realistic scope. Now that we'd found our problem, we did some research to see if anyone else had already invented a solution. A majority of the tools we found were relatively similar in concept to our abstract solution, yet each differed in one or two significant ways. Quad was a system that focused on creating digital groups instead of physical ones. OpenStudy aims to form groups outside of the college environment for general academic discussion, and Meetup was focused on grouping with others for non-academic purposes. StudyPal was the closest in concept to our idea, but focused on large-scale standardized tests such as the SAT, GMAT, and GRE instead of for everyday class use. We also examined tools such as GroupMe, Piazza, and ELC, as they do provide some functionality that's useful in the search for peers. But we concluded that their functionality, while useful, was too general to qualify as an adequate existing solution. Now that we had a problem that we were confident hadn't been solved, we transitioned into the design phase.
With the problem space locked in and the issue properly researched, the team came up with 3 unique solutions that could address the problem.
We started out with 3 fundamentally unique designs: a website, a physical kiosk, and a mobile application. We started with a website, which is a legacy platform that many users are already familiar with. The idea behind using a website really stuck out with us, as it gave us space in which we could demonstrate a wide variety of features. In its early designs, the website offered the basic core functionality of finding study groups, as well as tutoring and review sessions catered to the user. The system did, however, require heavy user input, leading to longer creation times and convoluted management. Its robust design, accompanied by the ability to educate users on the benefits of team-based studying, made the Study.com design a great contender. Our second design took a very experimental approach, in the form of a kiosk. We called it the Study Hub. Paired with a much smaller study buddy that was equipped in each room, it made for a quick and location-based study group search. This allowed users to just walk up to their favorite hotspots on campus to study and find other users in the building in which to study with. We really enjoyed the idea of finding strangers with similar study interests, as our research had recently proven that studying with friends can often lead to distraction. The system gave freedom to groups in each room with their study buddy, allowing them to set preferences and topics that others could see. This made the experience seamless for users that wanted to walk up, skip the typical login systems, and find precisely where the group is, using the Study Hub kiosk. Unfortunately, the kiosk system is quickly becoming obsolete, and the startup costs would be more beneficial when used elsewhere. With smartphones heavily integrated in our society, our third design became a mobile application called Study. This was the most logical step, considering the majority of our stakeholders are already familiar with using mobile applications. This would bring the learning curve down while maintaining the core functionality. A huge strength of this design is potential for using the university's central authentication system, preloading classes and other data on behalf of the user. Using integrated smartphone functionality, geolocation was another potential point in the application's favor. Location could be used to narrow down groups as well as forming groups based on proximity. Drawbacks of this implementation include less potential functionality than its counterparts, as well as only being developed for mobile operating systems.
The team consulted experts in the field and eventually agreed that the mobile design was the most sensible choice.
With the main focus now on designing a mobile application, we thought long and hard about how to best implement this design. Initially, we were going to go with our original product. However, as we began to develop and draw out the plan, we found it too clustered and ultimately it lacked appeal to the users. We realized that the mobile application had a lot of functions that were unnecessary and different from what we set out to do, creating a simple way for students to join or create small study groups. We decided to scrap the three main functions from the initial design: the geomap, the message board, and the ability for users to search for groups outside of their classes. The main reason for the removal of these tasks is that they made the interface messier and distract the user from the main purpose of the application. The final product has a simpler and cleaner interface. Going with the original idea, the user logs in with their university email and password. This allows the system to fetch classes from the university, with the home screen displaying classes the user is taking for the semester. Here, classes are color coordinated based on subjects with matching vibrant colors. The user can then select from two options: view their profile page or dive right in and search for study groups relating to that class. Let's head to the personal profile first. Here, the user can do three things: toggle their email to be public to others, look up more information about their classes, and review previous study groups. Time for the good stuff. Here is an example of searching for study groups related to the class Computer Science 4800. The groups can be sorted in three ways: time created, distance related to the user, and members in the group. Let's pretend to check on a group residing at the SLC. You can see that there are tags describing what the group is studying and what members are currently in the group. Tapping a member will take the user to that member's profile, showing their email, if public, and classes in common. Aside from joining a group, users can also have the option to make their own groups for this class. On this page, the user is prompted 5 things before a group is created: the location, time, date, the max number of people able to join, and tags for the group. We hope that with this simple and vibrant design, it will attract users to start and continue using Study as their main way of finding study groups.
With the design finished, the team set out to demonstrate the application on potential stakeholders, seeing how it would fare in the real world.
Obviously, when testing the application, we want to get the opinions of our primary stakeholders, which in this case were students. Our actual testing procedure had users follow a list of tasks that make up the core functionality of Study, namely locating and creating study groups. Each user was given the same set of tasks regardless of which evaluation they were doing. For the first 5 participants, we measured the time it took them to complete the outlined tasks, and then compared those results with keystroke-level model predictions of how long each task might take. Generally speaking, users took longer than predicted, but this can be attributed to the fact that they were each required to stop and read the directions at each step. Following the speed testing were the think aloud evaluations. We asked users to perform the same tasks as the first group, but this time we asked them to speak their minds and narrate the process. This evaluation method actually ended up giving us loads of directly applicable feedback because the user didn't have to figure anything out. They could just turn to us and ask a question or remark about something instead. The most recurring issue here seemed to be that users were slightly confused when asked to go to the home screen because we didn't properly explain what that was. And users also noticed they would prefer a persistent home button or some other way to access the home screen from anywhere in the application. Finally, we asked the last batch of users to comment and critique after the fact in a process called retrospective evaluation. Users were asked, number 1, what's your overall thoughts on Study? Number 2, was there anything good or bad that stuck out to you when using the application? And number 3, if you had to change something about Study, what would it be? While the retrospective evaluations yielded glowing reviews, we couldn't help but feel the users were a little bit too forgiving with us when talking about their experience, due to potentially the Hawthorne effect. In hindsight, we would have rather preferred participants focus less on politeness and more on objective criticism, which would have been more helpful to us. If we had more time to test, we would like to see how people use the application to actually meet up with other people, to gain insight to the usability of the application and experience of Study as a whole. There's a significant difference between simply testing the mechanics of the Study application versus seeing how the concept itself fares in the hands of everyday users. Regardless of how our interface design is received by users, it means nothing unless we can show that design supports a robust and effective method of bringing students together.